as I promised in the past couple of videos, we are going to be doing a problem today. And the problem that we're going to do today is going to cover acceleration and Newton's law for a system of particles. So we're going to consider three particles because we know how if the particles in a system all move together, the center of mass will move with them, right? So now we want to consider what happens if the particles move in different directions with different accelerations. And we're going to consider three particles. I'm going to draw an axis here just to illustrate how our three particles are distributed space-wise. So we have one 8 kilogram particle going in this direction at 45 degrees, and it is at 4 meters. So this is going to be 4 meters. And then we have another particle over here going F1. This is 4 kilograms, and this particle is 8 kilograms. Then we have a final particle over here, and this is also 4 kilograms, and it is going this way. Okay, so F1 is equal to 6 newtons, F2 is 12 newtons, and then F3 is 14 newtons. And we want to find the acceleration of the center of mass and the direction that the center of mass moves. So we can find our center of mass and mark it with a little dot. We see that it's somewhere around here because the particle on the right is 8 kilograms, which is bigger than both of them. So it's going to be shifted more to that particle. So we're going to label this as the center of mass. And the mass, we can treat the center of mass as if it were a real particle with a mass equal to the system's total mass, which is m equals 8 plus 4 plus 4 kilograms, which is just 16 kilograms. So that is our system's total mass. And we can now apply Newton's second law to the center of mass. So we know from a previous video that F net equals the total mass times the acceleration of the center of mass. Or F1 plus F2, remember these are all vectors because they're moving in different directions. So we can set the acceleration of the center of mass equal to the vector sum of all of these forces divided by the total mass of the entire system. And this tells us that the acceleration of the center of mass is in the same direction as the net external force F net on the system, because we know that the total mass m over here does not have a direction. So we can evaluate the right side by rewriting the forces in its component forms. So we have a center of mass in the x direction is just equal to F1x plus F2x plus F3x all over m. And this is, so F1 is just equal to negative 6 newtons, and F2 is 12 newtons. And then we're going to cosine of 45 degrees here, and then add 14 newtons. And then we are going to divide everything by the total mass, which is 16 kilograms. And then that will give us, if we plug it into our calculator, 1.03 meters per second squared. So that is acceleration in the x direction. And we can do the same in the y direction. We do F1y plus F2y plus F3y, all divided by m, and this gives us 0 plus 12 newtons sine 45 degrees plus 0 again, divided by 16, which gives us 0.53 meters per second squared. All right, and if we want to find the vector total ACM, the magnitude is going to be ACM equals the square root of ACM in the x squared plus ACM in the y squared. And we square root that. And that is just equal to 1.16 meters per second squared. And then we can find the direction or the angle from the positive x-axis as theta equals tan inverse of AY over AX, and that is going to give us 27 degrees. And now you have found the acceleration of the center of mass and the direction that that acceleration of center of mass is going. So now I just wanted to graph it out for you to show how it sort of looks like. So if we have the y-axis over here and then the x-axis over here, we had our original center of mass over here. So that is our center of mass. And then we had F1 going this way, F3 going this way, and then F2 going this way. Right, and then our total acceleration was going somewhere this way. So this is our ACM, the entire component of it. And then this over here is theta, where theta we calculated before is 27 degrees. So this is how our particle is moving. So that is a problem on the acceleration of center of mass and Newton's second law for a system of particles. In the next video, we're going to talk more about momentum and how we can use that to solve problems. But I hope you guys have learned something new, and I'll see you in the next video.